So the next speaker is a head of DevOps advocacy and developer of advocate at JFrog. The person who will visit us from United States, and Baruch Sadogursky. I hope I pronounced your name properly. Baruch, can you hear us?
Yeah, hey, can you hear me?
Oh, you have the most awesome hat I have seen like in months. Yes.
Thank you.
Do you have glasses on it?
No, it's actually like there is nothing, it's clear, but I think for of the next one, and I might have something fun with it.
Cool. Cool. So Baruch, I guess I will let you on the stage, and well, we will enjoy you.
All right. So I hope you can see my screen now. Can you?
We can.
Perfect. Okay, let's get started. So today we're going to, oh, that's not the right slide. Sorry about that. Here we go. Yes. Today we're going to talk about DevOps patterns and Antipatterns for continuous software updates. And it's basically talk about what can go wrong when you update software or when you want your users to update software. And the first question before we talk about what can go wrong, we need to ask ourselves why people update software at all. Obviously, there is software that not supposed to be updated at all. Here's an example. BC is a shell calculator that was updated last 20 years ago. And it was updated 20 years ago because in the last 20 years, the shell didn't change and the basic rules of math didn't change. So there is really no reason to update, but this is an exception. This is an exception because of mainly two reasons. The first is us. And when I mean us, I mean the users. We are all users of software in this way or another. And if there is one thing that we want is features. And when do we want those features? We want them obviously yesterday, worst case scenario now. If we want more features now, it means that the vendors of the software need to provide us with those features as fast as possible. Just for you to realize how this process accelerated in the last years, think about your first mobile phone back in the 90s. It has, you could dial with it and text with it, and maybe it has Snake, but that's pretty much all. And you didn't have much expectations from it. I mean, this is what it does and it's fine. Today, for your smartphone, you want as many features as possible. You want as many apps as possible. You want features in those apps. The great example is banking mobile app. I, for one, switched bank over features in the mobile app. I wanted better features. My bank didn't provide it. They lost my business. This is how important the features are. Another very important reason are security vulnerabilities. And someone once said security vulnerabilities are the new oil spills. They are as important because now everything runs on software. Actually, oil spills become less important as we transition to alternative energy, and security vulnerabilities become even more. In some point of time, we will see one overtaking the another. The way to think about security vulnerabilities is that it's multifaceted. Here's an example from something that you might remember when you got your driving license. When you got your driving license, you learned about stopping distances. And stopping distances are a combination between thinking distance and braking distance. The thing with them, that they are of a completely different nature. Thinking distance is how fast the neurons from your eyes reach your brain and how fast the brain tells the legs to step on the brake. And braking distance is about the friction between the brakes to your wheels and from your wheels to the road, to the pavement. So they're completely different. But if you want to reduce the stopping distance as much as possible, you need to think about both in different ways. And it's the same with security, reactive security in this example. If you have a breach, you need to know that you have been breached. You need to identify it. You need to fix the problem, and then you need to deploy your fix as fast as possible. And again, the technology here is completely different for all three of them. But in the end of the day, the faster combination of three of them is particularly critical. Here are a couple of examples. Ransomware in the National Health Service in the UK brought down many hospitals 3 years ago, and that's because they run a very old version of Windows. They didn't update their dependency, in this example, to the operating system, and that caused very big problems. Another one is obviously Equifax, the story that you might heard in the United States 3 years ago. Chinese hackers hacked into one of the three biggest credit reporting agencies and stole credit records of tens of millions of users, hundreds of millions of users. And that was, again, because a dependency wasn't updated in time. There was a vulnerability in Struts component, and it wasn't updated, and this is what happened. So basically, the problem is that you need to update as much as possible. Those two examples are examples of kind of companies that fell behind on their update routine. They didn't update when the fix was already available, but with vulnerabilities like Meltdown and Spectre, it's even worse, because with Spectre vulnerability, for example, you don't know that the breach is even possible before you have been breached. It's inherently 0 day. And that means that you cannot prepare for it. You cannot say, well, I'll update all my dependencies and I will always be on top of things. There is no such thing anymore. You need to, when you discover that you have been breached, it's already in progress. So you need to update as fast as possible. So basically, that's the second reason for updating as fast as possible to react to security breaches. And we know that companies are already doing that. If we look at the State of DevOps report that you are probably familiar, and if not, you really have to familiarize yourself. That's the most important report, scientific report in our industry, and it's very serious. They canvass 31,000 people to come up with the results. And if you look at the results of the last year, 2019, you can see that 20% of the organizations are what the report calls the elite performers. Elite performers do DevOps right. One of the things that they do right is the deployment frequency. How frequent, how often does your organization deploy code to production or release it to end users? And you can see here that the elite performers actually do it on demand. On demand means when it's need to be done. We have a new feature, let's deploy it. We have a security fix, let's deploy it. It's done immediately and can be done multiple times a day. How comes? Well, that's because it's not a new idea. You can see how it traces back all the way to extreme programming in 1998. 22 years ago, 23 years ago by now, short feedback. That was extreme programming advocated. All the agile methodologies are talking about shorting the feedback, releasing faster. Scrum 2000, reduce cycle time to an absolute minimum. The production system or lean manufacturing, decide as less as possible, deliver as fast as possible. And Kanban, incremental change. All the agile is based on the idea of releasing faster. This is why a lot of organizations already do it. And let's talk about why and how you can do it too, or what not to do if you try to do it. So my name is Baruch Sadogursky. I'm the Chief Sticker Officer of JFrog. That's my official business card. If I were with you as person, and hopefully next year I will be able to give you some awesome JFrog stickers. But I'm also a hat of developer advocacy or DevOps advocacy with JFrog. My Twitter handle is on the slide. Write it down because you will need it in the end of the talk. And if you didn't write it down, no worries. It's in the bottom of every slide. So that's fine. The most important slide of this talk is this one. If you go to jfrog.com/show notes, you'll find there a page dedicated to this conference and this talk, and you will find the slides that are already there. The video, I will update once the organizers share it with me. All the links to everything I mentioned by now, including Equifax and State of DevOps report and everything that I'm going to mention during this talk, everything is already there. The place to comment, to rate, and a very, very nice raffle of JFrog t-shirts, amazing JFrog t-shirts that are here to give it to you for thank you for being here. So again, this link is also, as you can see, in the bottom of every slide, so you can always go there even if you didn't write it down. It's all there. Okay, now let's get to it. So you wanted to update faster. And I will give you the example of organization that wanted to update faster, and that will be the Java organization within Oracle. More than 3 years ago, 3.5 years ago, Mark Reynolds, head of the Java platform in Oracle, decided, Mark announced it, that they are going to move faster. Instead of the releases when some scope of features were ready, they decided they are going to release, and whatever features make it, they are going to release every 6 months. That was, as I mentioned, 3.5 years ago when Java 8 was the last released version. Since then, they released Java 9, Java 10, Java 11, Java 12, Java 13, Java 14, Java 15. 7 new versions are out there, and let's see what's going on and how is this fast-paced release cadence works for Java. So we can look at the state of the developer ecosystem report that was out last month. And if we look at the numbers of Java version adoption, you can see that 75%, 3/4 of the industry are still on Java 8. That's the same Java 8 that was out when Mark announced they are going to release faster. And this is, first of all, confusing, because I hope I convinced you that we need to update faster. And here we go, Java is updating faster, but no one accepts those new versions. No one uses the new version. And the real question is why? To understand why that happens, we need to understand how do we update, how our thinking process works when we see there is a new version. So here we go. Update is available. Do we even want it? If we don't want it, it will be just no. I mean, Java 9, no, I'm not going to take it. If there are interesting stuff in it, the next question will be, are there any high risks? If there are no high risks, again, no problem. Example can be Java version on your personal machine, developer machine. You go like, oh, there is some nice features. Let me try it. You try it on your developer machine. Worst case scenario, your project doesn't build or doesn't work. You're going to roll back to a previous Java version and no harm done because there are no high risks. If there are high risks, the next question will be, do we trust the update? Or put it another way, do we trust the vendor of this update that this update won't break anything? Today I have a very hard time finding an example of the relationship in which you reply yes to this question. And this is the biggest problem in our industry. We don't trust our vendors. And the question is why? Why we cannot take the next version of Java, or if you wish, the next version of the operating system for our Mac and just install it. Big Sur is out for a couple of weeks by now. Did anyone update? I did, just because I'm crazy, but more reasonable people, none of them updated. Why? One reason is they don't know how to test. None of the vendors that we are working with, not Oracle, not Apple, no one knows how to test. And that's obviously a ridiculous statement because it's wrong. We've been testing our software for decades and we are pretty good in that. We know exactly what to do. So that's not it. What else? Complexity. Complexity is skyrocketing. Our software, because of our demand for more and more features, the software becomes more and more complex and it's harder to test. Also, data. More and more companies become what we call a big data companies. Now it's not out of proportion to think that some just consumer software uses big data and machine learning for stuff. We in JFrog do that. We collect more and more data and we use it in machine learning for better support, for better recommendations in the tools, for making the software better, but it means also that our software is harder to test. If we have a lot of data, the staging in its classical form, when we say we're going to set up a staging environment, which is a copy of our production environment, and we are going to test everything, it's impossible anymore. It doesn't make sense in terms of complexity. It's very hard to set up a production-like environment. And in terms of data, it's very expensive to create production-like environment. We are not going to do that. And that means that we release software which is not as tested as we like it. And this is why our customers don't trust our updates. The next question, if they don't trust, is can the customers verify the update? Sometimes the answer is no. If it takes me as a customer 6 months to verify a Java version, and in 6 months it will be a new Java version, there will definitely be versions that I will skip just because why would I bother? But even if I decide to do the verification, it takes time, it takes money on my part, and it basically makes me reluctant from taking updates. Now, this problem creates an incentive for the vendors to put more food on the table. They want to make the updates more lucrative to us, the users. So in fact, we have a trade-off because between features that we as users want that the vendors put on the table and the time and the cost of the acceptance test that we need to invest in order to take the feature. That creates a vicious circle. Vicious circle that says, well, we want to update because we don't trust the update and it's too expensive and that we don't want it. The vendors add more and more features to every release to kind of convince us to update. Look at all those features, you want them. And that makes updates even more dangerous because now the updates are even bigger and harder to test. And this is a vicious circle that goes on and on forever. And the question is there any cheat that I can break the vicious cycle with? And there is, and a lot of companies do that, and you live through it every day, right? So update is available. Do we want it? Now it doesn't matter because a lot of updates, more and more apps are auto-updatable, and they do it for the software that doesn't have high risk. For example, your browser. Most of the people in the audience, I'm 100% sure, don't know which version of the browser they run because it's auto-updates, and that's because it's a relatively low risk. It's fine. It's not like production environment. It's on your machine. Every SaaS in the world, again, uses auto-update. You don't know which version of the website you are looking right now. Most of the apps in today's smartphones are set to auto-update. Again, they are low risk. Worst case scenario, if Netflix installed a new version and it doesn't work, you are going to watch YouTube for a while until Netflix fixes it, etc., etc. But when it comes to critical applications with high risks, for example, the OS in your smartphone, here is where your the smartphone itself will ask you 3 times, are you sure you want to update? Because this is high risk. So how do we lower this risk? How do we go about having less risk around updates? Let's see what goes wrong and how can we battle it? So I'll start with a personal story. 3 years ago, I was in a conference, like physical conference. You remember, you bought the plane and you flew over there, and then you were there with other people, like incredible stuff. And my wife is calling me and she's like, Baruch, I came home from work and kids are sitting in the dark. And I'm like, what happened? Do we have like a power outage? And she's like, no, the power is fine. We have an internet outage and the kids are yelling, Alexa, turn on the light, Alexa, turn on the light, and nothing happens. So obviously that day the kids learned that there are physical switches on the wall, and we went to investigate the internet outage. Our internet provider claims that everything is fine, and then we got this email. And this email goes like, oops, sorry about that. Your router has been reset to its factory settings by a software update. And now we cannot reach the router because it's not connected to the internet, so we cannot fix it. Go ahead and set it up manually. And obviously that's a problem. And the problem here is that if an update went catastrophically wrong and the over-the-air patch cannot reach the device, then we have no way to fix it. And it takes human intervention that can be very expensive, very time-consuming. Think about a solar panels farm somewhere in the desert, right? Loses money and time. What's the fix? What's the pattern? Local rollback. Have a previous version saved on the device prior to the update and the rollback in case the problem occurred. The thing is, this pattern is not new. This is a screenshot from Windows 98. Unfortunately, I didn't find a screenshot for Windows 95, but even from Windows 95, we have that. When you change a resolution on in your Windows, because you have like a new display, you will see this. Your desktop has been reconfigured. Do you want to keep those settings? And they come down. This is a local rollback. They check if everything is fine. You approve that everything is fine and you continue, or it will roll back. It requires manual intervention. You are the one who needs to click like, okay. Obviously, in a local rollback automatic mode, the upgrade system, the update itself should check that everything went well using observability. We're going to talk about observability in a second. And you might say now, well, you talk about IoT routers, that's really not my domain, but it really is. The principles are exactly the same no matter what you update. It's even the same for updating cars. Let's talk about updating cars. That's a fascinating topic in what can go wrong category. This is Jaguar I-Pace. It's a very nice electric car that was released last year, and half a year later, they recalled each and every car they sold because they have a bug in the brakes. And you might say, well, that's important, needs to be fixed. Another example, very similar, happened a year later, this year, like this October. Another great electric car, Polestar 2, had to recall all of their cars that have been sold because of software errors. Again, they had software bugs. Jaguar, the Polestar, had over-the-air software updates. And the problem is not having software updates, is that they need to fix the things manually. And this is very important and not more very expensive, and not more important, it's impossible to force. So you have a problem with your customer's car, the brakes. What do? You're going to send them an email and the mail in caps and red envelope. That's all you can do. If they decide not to come, they won't come. And if there is an accident because of the bug in your brakes software, you as a vendor will be liable. And this is obviously something that we don't want. How do we fix it? Over-the-air updates. Then we can push the fix for this bug to all the cars. The only thing that is better from over-the-air software updates are continuous over-the-air software updates. What's the difference? Let me demonstrate you on another car, and that will be Tesla. Tesla does over-the-air updates, and they're very good with that. Well, they're good with that, and they release those updates in about every three weeks. They have a bug in their driver assist system that it's called the phantom braking. And the phantom braking basically slams on the brakes without any reason because it thinks it saw something that wasn't there. Now, obviously, people who use the autopilot are very upset and they very vocal about it, and they're waiting for the fix, and they're waiting and waiting and waiting, and the fix doesn't come. In the end of the day, when it comes, it turns out why it took so long. It took so long because it was released together with chess. Well, why chess is important? Because when you charge your car in the supercharger, you want to play chess while you wait. And also the bug fixes that allegedly fix the phantom braking. Obviously, people were very upset. They said, hey, why you waited for 3 weeks for chess to be released? Why you didn't release the fix for phantom braking when it was available? Now, there is another group of people, and those people who play chess, and they probably don't use the autopilot because it's kind of beta and they don't want to risk it. Instead, they are smart people, they play chess. Those people are also upset. They said, hey, we needed this chess as soon as possible. Instead, we are waited for a bug fix for a feature that we don't even use. No matter how you look at it and how you judge what's important, when you do updates in batch, important features wait for non-important features. So instead of batching the features together, you should really implement continuous updates and release the features when they become available. You have a fix for the phantom braking, ship it. You have chess, ship it. Don't wait for other features. I understand there are marketing considerations for batch updates, but if you market it right, continuous updates can be even stronger marketing message than, hey, there is a new features with a bunch of stuff in it. Let's talk about server-side software proper, and this is kind of our world. Here's an example from almost 8 years ago now, and it's a canonical example of software update goes wrong. Knight Capital, it's a trading firm on Wall Street, and they decided to update their software after years of using an old version. It was literally years between the updates. They decided to reuse all the APIs, and there's flags that now did something completely different, like sell instead of buy or something like that. And they just forgot to update one of their 8 servers. So some of the new clients keep sending the orders to this old machine running old code, and it obviously did something wrong. And they noticed it, and what did they do? They undid the entire, they took down the machines that are upgraded because they assumed that the new updated machines do their own thing. And now 100% of the request obviously went to the non-update server, increasing the problem instead of fixing it. So no monitoring, no alerting, no debugging. 40 minutes later, they fixed it, and they lost $400 million, basically 10 million a minute of when they tried to debug it, and eventually went out of business. What went wrong here? Tons of stuff. First of all, manual updates. People suck at repetitive tasks. There is no surprise that they forgot to update one of the servers because people tend to forget things. Instead, you automate everything. Machines won't forget to update the 8th server out of 8. Another problem, the update came after years of not updating software. And you might say, well, that's fine because they didn't need to update and everything. Why update when you don't need it? And the answer is because when you do need it, you need to be able to do it with skill and habit. And repetition, if it hurts, do it more. Repetition creates the skill and habit. And some companies even run dry runs of updates when they don't have anything to update, just to make sure that people are up to date with how software needs to be updated. State awareness, they reused all flags. Probably there was good reason for that. But when you do it, you need to be aware of the consequences, and they obviously weren't. More so, when you revert it, this is what they try to do, they need to be aware of the state. Again, require a reverting for the state. So what they ended up with is the new clients calling all the APIs, and after they reverted, it kept going, and this is why they had the problem. Another example, Cloudflare. Cloudflare went down a year and a half ago and took like a huge chunk of the internet with them. What happened? Well, Cloudflare does internet routing, and they change their routing rules frequently to make it impossible for their attackers to know what traffic goes where. And they made a mistake. They misconfigured a simple rule, one of the rules, and the rules are done in regex. So the error there in the regex spiked the CPU to 100%, and then this data center fell, and the increased traffic on another data center that fell as well, and there was a chain reaction, and the next thing you see is affected region Earth. They took like entire big chunk of Cloudflare infrastructure down. What was the problem here? The release of the rule to production to everybody caused the problem. And the solution here is something that we know how to do again for years. Releasing a bug affects all the users. Instead, release to a small number of users first, effectively reducing the blast radius, and observe. If the problem occurs, stop the release, revert the update for the users. Now, the thing is, again, this concept is with us for years. It's actually, all of us learned it when we were like, I don't know, 8 years old, when our parents taught us how to do laundry or to how help with the laundry, right? When you take any fabric treatment, you can see always spot test on hidden service first. That's progressive delivery. You try it on a small piece of fabric and see how it goes. If it's okay, you apply it to everything. If not, you don't do that. This is progressive delivery, and it should be done with software as well. Progressive delivery always should come with observability, because learning that your software doesn't work from complaints on Twitter is not a very effective way to debug when something went wrong in your application. And observability is the 3 pillars, you know, tracing, monitoring, and logging. That's a topic for a completely different talk. Rollbacks. When something went wrong, instead of waiting for a fix, you just want to roll back the affected users immediately to the previous version without delay. This is obviously, again, something natural, but sometimes rollbacks are not available. For example, if you are a mobile developer, you probably know that not Play Store and not Apple App Store support rollbacks. Then you can try and mimic the rollback capabilities within feature flags. You can embed 2 versions and then with API flip the switch for whoever suffered from a bad update to the previous version, or disable the feature that misbehaves. Now, the funny part is that exactly a year later, July 2020, Cloudflare did it again. Again, big chunk of internet was down, and that was again because of a regular expression. They did maintenance on New York, Chicago segment, and then they wanted to route the traffic through Atlanta, updated the config manually, made a mistake in regular impression. All the traffic now route through Atlanta. Obviously, Atlanta is not capable of the load of the entire internet. It crashed, and then the error propagated through their entire network, chain reaction. Next thing you know, affected region Earth. And that's obviously, again, the same problem. And here, automated deployment and checks and progressive delivery and everything that we spoke about could actually help. People suck at repetitive tasks. You need to be able that you automate everything, including the testing of the regular expression that comes with it. So to summarize, continuous updates are frequent, are automatic, are tested automatically, are progressively delivered, state aware, have observability, and if needed, that's kind of an extra credit task, have local rollbacks. We want to get to a situation when if update is available, it doesn't matter if you want it or not, it will be set up automatically, not only for the software which doesn't have high risk, but also for the software that do have high risk because we trust the updates. And then we can update all the time. So our goal is to transition from bulk and rare software updates to extremely tiny and extremely frequent software updates. So tiny and so frequent that they will provide an illusion of software flowing from development to the update target. We call it the liquid software vision, and one of the JFrog co-founders, Fred Simon, came up with this vision, and we liked it so much, we wrote a book about it. Two co-founders of JFrog, Fred Simon and Yoav Landman, and yours truly, wrote a book called The Liquid Software. And to thank you for being here today, I want to give this book to you. If someone wants a hard copy, a physical book of Liquid Software, ping me on Twitter, my DMs are open, and I will be happy to ship the book to you as a thank you for being here at this great DevOps Unicorns conference. Are there corner cases? Yes. Is there a lot? Less than you think. For example, how about updating a plane mid-flight? Airbus A350 has a memory leak. It has to be restarted every 150 hours. Boeing 787 has a register leak. It should be restarted every 51 days. Let's say you are flying now through the Pacific. There is no land in sight. And then the pilot asked the co-pilot, hey, did you forget to restart because 150 hours are almost up? And the co-pilot said, oh, no, oops, we forgot. Wouldn't it be nice to update the plane and actually fix the bugs in this situation? Of course it would be. It can even be done? Can we update a plane mid-flight? Yes, and this also already has been done. Boeing 777, many years ago, 20, 30 years ago, did software update mid-flight when they tried to debug their turbulence stabilization bug. They put all the developers on the plane, took off, went to where the turbulence is, debugged it mid-flight, patched it mid-flight, verified that the problem is solved, and then successfully landed. With that, thank you very much. I'm at Baruch on Twitter. Ping me for the book. Liquid Software is the hashtag for our vision. If you want to mention it on Twitter, that's the hashtag to mention. Also mention the DevOps Unicorn Twitter. They are doing a great job in organizing this conference. And liquidsoftware.com, this is where you go to read more about the vision and the book. Show notes, don't forget, jeffrog.com is a show notes. This is where you go for the slides, all the links, and the raffle for JFrog t-shirts. And with that, thank you very much.
Very much, Baruch. We are really happy to have you, and you had a just awesome speech.